In this video, I'm going to teach how does the min-max algorithm and alpha-beta pruning algorithm works. As you know, these are located in the game theory problems of artificial intelligence, and I want to explain some of the specification of these algorithms, which min-max algorithm and alpha-beta pruning as sequence using this sample graph very easily. So I start with min-max algorithm. This algorithm used in game theory problems. We start from the leaf node to reach to the root, and in every level we should pay attention to its type. If it is minimum, we should choose the minimum value, which means we try to give the minimum score to a rival. And if it is a maximum, we consider that it is our turn, so we try to earn the maximum value. So let's see how does min-max algorithm works here. I choose my pen and let's start. Okay. At first I just separate the levels here. We have two levels, max and min, as I explained. I just separate them, and as I told you before, let me correct it. As I told you before, we start from the leaf. Okay, here in the leaf we have the values, so we have the empty nodes here, we should fill them and choose the best, choose the related value. So we are located in the minimum value. In the first step, in the minimum value, we are trying to give the minimum score to the rival. So between the 2 and 4, we choose the minimum one, so we choose here 2, and between the 4 and 3, we choose the minimum one, so we have choose 3 in the first step of the min-max algorithm. So in this step, we have this one, so again I separate it here, and as you can see, here we just choose 2 here and 3 here. And now in the second step we are in the maximum level. In the maximum level we try to take the maximum value. Between 2 and 1 we choose 2, and between 6 and 3 we choose 6 here, and we go to the next level. Again I separate the levels here like this. I again fill them. Okay, we have 2 here, we have 3 here, we have 2 here, we have 6 here. So we are now located in the minimum level. So in the minimum between the 2 and the 6, we choose the 2 for the minimum level. And in the last level, we have the maximum. I separate it here again, and as you can see, we have 2 here, we have 3 here, we have 6 here, we have 2 here and 2 here. And in the maximum value, we have the 2. We have to choose between 5 and 2. We choose a 5, and we solve this like this. As you see, we check and control all the values of the nodes here in the graph. We have a better algorithm that called alpha-beta pruning, which in this algorithm we do not need to check all the values of this graph. It is like min-max, and just prune the unrelated branches in the tree. We start with alpha equal minus infinity for maximum value, and beta equal to positive infinity for minimum value. We start from the root and then pass alpha and beta to the children nodes. At every level we compare the alpha and beta value with the current content and update them. If it is minimum, we compare with beta, and if it is smaller than it, we update the beta value. And if it is a maximum, we compare with alpha, and if it is bigger than it, we update alpha with it. Whenever we have the equation of alpha bigger or equal than beta, we prune the branch. This is very important point. This is where we prune the unrelated branch and does not need to check all the values of the node. So let's see how alpha beta pruning solves the same problem. Here, let me choose the pen. Okay, so our prune condition was alpha bigger or equal than beta here, and we start with alpha equal to minus infinity, beta equal to positive infinity. So we start from the root here, vice versa of the min max. I separate them and let's check what happened. So we are here, we have value here, so we do not need to do any change. We are located in the maximum value here. In the maximum value, as I told, we check for the alpha and we choose between minus infinity and 5. Which one is bigger one? 5 is bigger one. So alpha would be updated to 5 here. Means we change the alpha as 5 and beta to infinity. So in the next level we have here alpha equal 5, we have beta equal infinity here. Okay, we just go deeper. Here we are coming here and pass the value here. So we have alpha 5, beta infinity, and then again go to the left side. So we come here, alpha is 5, we transfer the values, and beta is infinity, and then we come another level down and see we have a 1 number here. So we are located in the maximum level. In the maximum level we check the alpha value. Okay, we check the alpha value. Is 1 bigger than the alpha value, which is 5? No, it is not. So we do not change it, and we check it and then go to the right side here. Okay, let me see. We come here with alpha, we come here with alpha equal 5 and beta equal infinity. Okay, so we check the left side again. We are located, let me write it in the another slide. Okay, I just separate the heads here. We are located in the minimum, and alpha was 5, beta was infinity. It was alpha was 5, beta was infinity. Okay, so we look at the left side and we see we have the 4. Okay, we're located in the minimum level. In the minimum level we look at the beta and we compare which one is smaller, 4 or infinity. Of course 4, so we update it to 4, and we check the equation of alpha equal or bigger than beta, and if you see 5 is bigger and equal than 4, so we prune it. Means we do not even look at this edge. Okay, we have the value of 4 here and 5 here. We will have 5 here and we have infinity here. So we go back to this level. We are located in the maximum level here. So in the maximum level we look at the alpha. Which one is, we are looking for the bigger number. We have 5 and 4, and the alpha value is 5. It has taken the highest value, so it does not have any change here. And then we come again to this level. Let me write it in the last slide. We have something like this here, 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 here. Okay, we have alpha equal 5, beta was infinity, and from here we have the, I think we have here the value. Let me check this slide. Sorry. Okay. Some problem from the operation system. Okay. We have alpha equal 5, beta equal to infinity. So we have alpha. So we are going to back to this level. We are located in the minimum. We have alpha 5, beta infinity. So we have these values here. We are in the minimum, so we look at the beta, and if you see which one is between 5 and infinity, which one is smaller, between all of them, the 5 is smaller. So we have updated beta as 5, and we have the equation of alpha bigger or equal than beta, 5 bigger or equal than 5. So we prune this, which means we do not need to look at this. We just prune this and prune this one. Okay, we just check. As you see, a fewer, half of them almost half of the nodes here, and the value here would be 5. If we go back to here, the maximum value between 5 and 5, which was a 5, so we reach to the 5, which is our solution by looking at the very lower nodes. This is a difference between the min-max and alpha-beta pruning.